Hey guys, it's Ben with Myers Woodshop. Today we're going to go over something for the yellow and black laser you can see I have behind me. I did a previous video about that. Was it worth it? And the answer is yes. So now we're going to look at something I got today. It is the rotary, so we can do cups and circular things and Yeti cups and stuff like that. So I purchased this off Amazon, and to all those who have purchased things from the links in my description of the videos, I can get things like this because you do that, so I want to thank you ahead of hand. So we're going to open this up, we're going to see how it does and see if it's worth it, and then we're going to install it into the machine. I'm going to use Lightburn software to control it. We'll figure out how to do that, and then we'll laser some round stuff. So let's open the box and see what's inside. First thing you'll notice is that it came from China, even though it was purchased on Amazon. It does arrive DHL, and you do have to sign for it. So we have a good amount of packaging. Feels like it comes all assembled here, and it looks that way. So that's the unit itself right here. So it's got a good amount of padding. And basically saran wrapped. Pretty heavy. Oh, this is off tilt. I don't know if that's something that can happen, but we have some rails, and you can slide this along. Looks like that way. I don't know what this... Oh, we turn this here, and this raises up. Okay. And what does this do? Oh, this raises it up, and if you want to lock it in place, you turn this one here, and it locks the metal rail. So you can raise and lower it depending on the wheels. These wheels spin really nice. They have a rubber coating on here so we don't mark. These wheels spin. They're of course connected to the stepper motor, so I can't really spin them. But they also have the rubber coating on it, so anything you put on here is going to be protected. You can move this in and out, and it has a bolt on the, or a locking handle on the other side, so we can stop it. All right, so maximum travel, we go from wheel to wheel. That is 1 foot 12 inches, or 300 and almost 10 millimeters distance here. You cannot spread these wheels this way or that way. They are fixed where they are. I have no idea if that's going to make a difference for what we're going to do. Mostly Yeti cups or something like that is what you're going to do with that. Let's take a look at that side. Okay, so on the back side here, the reason mine was tilted is that these can come out and they're not tight enough. So I'm going to go ahead and just get an Allen head and adjust that. They are slotted, so you can slide them side to side, and I'm assuming we really need to line that up with the center of that one up here. So I'm going to try to do that with some sort of dowel rod or something to get it straight parallel to these rods. So a little adjustment from the start there. Fantastic. Okay, so what I'm doing here, I unscrewed these bolts that were inside so I can move this head. And what I think I'm going to do, I'm going to put my woodpecker square in here, and it has right in the center is a 0, so I can kind of find center. And we're going to theoretically assume that these rails are aligned with each other. They look about like they are, so I'm going to make a mark there, and I'm going to come down here and do about the same. And even with this mark, it looks about the same. So I'll make that mark, and then I have a straight line in here. Now if I connect those two marks, I can look visually down and try to align the center of these wheels with the line. And it is different than the way it came, for sure. But I think we're pretty close right there. So this is how I'm going to do it before I know what I'm doing. It looks about right to me. We'll just take our Allen key and tighten these back up. A lot of the bolts on this were loose, so I'd recommend going ahead and checking every bolt when you get it. Make sure everything is tight and it won't move. It did get sent from China, so maybe that's why it's a little loose, or it's just quality control is pretty poor. So either way, I'd like to make sure that we're aligned in every way we can. Okay, so that should be about right. So I've got a dowel rod I can stick in the center here, and it does look about straight, and when I spin it, I don't really see any wobble in the dowel rod. Looks pretty straight, so we'll count that as good. I do see something here in the back. When I was putting the dowel rod here, I raised it up. So if you lower this, where you take this and then we're gonna lower this part down by going like this. And the unfortunate thing is it takes a while. So if you lower it all the way to the bottom, not that you're necessarily going to have something sticking all the way out, but if you lower it all the way to the bottom and you put this in the way, have something stick out. This is too far up and it won't allow this to sit inside. You can see I can't sit it up here either. So I don't know how to really change that. If you have a longer thing, you want to go longer than what you're doing. I've thought about a baseball bat. I'm not sure how to align that. Maybe take this off and make it shorter. Use a shorter one. I'm sure we can hack that in some way. But that is just something to be aware of when you get this. In order to alleviate that, we can raise it up high enough to where now it's almost, let's see, just about, yeah, we're about there. Now it's high enough to go around, but we're no longer parallel. This end is actually up higher. You can see this way. You see this end is up higher and this end is down lower. So if you're within the confines of the 1 foot working area, you're good. If you're anything longer than that, something's got to give somehow. Not exactly sure how to fix that yet, but we'll come across that bridge when we get to it. Next item is to consider when you're getting this is the connector. Now my connector is a 2-phase. You can see that there's 4 pins here, which means it's a 2-phase. And if there's 3 pins and not 4, it would be a 3-phase. It's weird that 4 pins makes it a 2-phase, but it does. So that's the connector we got. I'm going to show you where I'm going to connect it in my laser. All right, so we're over at the laser, and now we'll open it up and we have it turned on. I'm going to bring the laser forward using the controller. So what we're going to do is remove the Y-axis controller, which will stop it from going forward and backwards, but we will be able to go right and left on the X-axis. So where we're going to connect it to is right over in this corner. So let me bring the camera around and I'll show you what I'm talking about. So we're looking in on the right, and you can see over here we have a connector. I store a bunch of things in here, so all we do is unscrew this connector and pull it up. We'll unplug that connector. You can see we have 4 female holes here. Let me bring you in closer. So we removed that X cable that controls us going back and forth. We have our plug down in here. So our machine came just like this with this male plug, but we have a male coming out down there. So it's got an adapter in the center. So we'll just unscrew this adapter. And that's nice in case you ever need an adapter for a different machine. And now we have our female plug that looks exactly like the plug that was plugged in. So all we're going to do is take that plug and plug it into the plug down there. And we'll tighten it down. And then screw the locking screw. So here's our rotary, it's plugged in. I just have it setting up here so you can see as I control it on here, it'll move up here. So normally this will be the up and down and left and right. Our left and right still works on the laser, it's moving the laser head, but our up and down is actually going to be moving. You can see the wheels turning up here, and then down reverses the other way. So we only have so much of turn. It will stop eventually because it thinks that it's actually the head and your bed can only go so far. But that's all we'll need to get a full rotation of whatever's on there. So that's it. That's all it takes to connect. So I find it easiest to do when I remove the honeycomb. So I pull this out, and also depending on your laser and your rotary, you might have to go down that much farther because your cup is so big and your head is so close that it won't fit. So I remove that. Now we got to remove the bed all the way down. On my machine, I have a knob over here that I twist and it goes up and down, but I need to move the bed all the way down. So here's a little hack that I do. I'll show you that. All right, so what I do is it's got a little Allen key nut there. I just take my Allen key and I loosen it. I don't know why it's on so tight. So I just loosen that to where I can pull it off. I set that aside. Then I get my drill with nothing inside and I stick it on there and I tighten it down until now I put it on the reverse and I pull the trigger. And that's a whole lot faster than me going up and down with this stupid knob. So I'll put the knob back on once I get it close to the bottom. And now I can fine adjust the depth of what I want to cut. All right, so we're looking in my laser. And I'm going to grab the rotary and we're going to set it inside. Now you see we can set it facing this way, or we can set it facing this way. And I'm going to face it this way because if I don't, then the way Lightburn is orientated, everything will be reversed. And I'll have to do another step in Lightburn and change it. So if things are coming out reversed, you can either reverse it in Lightburn, which is an extra computer step, or literally put your rotary the other way around. So I'm going to do it this way. So here's my cable. So I'm going to find my Y over here. Here's my Y. I'm just going to unscrew this. I keep my extra pieces in here. Pull that out. Then I'm going to get the rotary and I'm going to line it up and then screw it in. And that's it for that part. That's how you attach the rotary. Once you plug that in, it's going to move the wheels as it would the Y going back and forth. We can move the X left and right, but if you see I move the wheel once, it moved the wheel here. So we need to move this forward. So we can slowly pull this forward like this to try to line it up with our thing. That's usually what I do. Or before you disconnect this, move this forward and then you can position your rotary underneath it. I just pulled it forward. If you want to yell at me for moving the axes and ruining the motors, then go for it. So now we have our rotary all underneath. We're ready to put a cup in. So this is the cup we have. This is what my wife chose for the kids. And I am going to put it either this way or this way. So what this machine likes to do is when it's spinning, the cup likes to roll off this way. So I try to get it to touch this lip right here. I may come up with a 3D printed piece to hold it inside. But if I can get the cup to kind of turn and rub against this metal piece, then that stops it from rolling away. So we're going to put the cup here. Now our cup actually fits kind of in there, but we want it a little closer. So we're going to loosen this and just or we're going to loosen this knob down here, and then that allows us to go forward and backwards. So maybe about here would be good. So I'm going to go tighten that nut in the back. Now we want it to go down because it is angled. This end is up. So I'm going to loosen this one, and that brings it down and up. So if I loosen that, it's going down. And what we want is a small level. So I'll put a level on there. We can see the level. We have a long ways to go. So if we loosen this back here, that will loosen the lock on the side to go up and down. So our level is just about there. We're level there, so we're going to lock it using that. So now our cup is in. We're level. We want to move the head over to make sure we're far enough away. And I'm going to move it forward because we're not quite at like the peak roundness. We want it at the peak roundness. So probably about there. Then the other thing we also need to know is the focal distance from here to the laser. So you can loosen, if you're, for some reason your head is down, you can just unscrew this here and move your head up and down. This does not change the laser at all. It just gives you more distance. So I like to move it all the way up when I'm lasering. And then here is my focal length, since mine doesn't have a motorized axis. So I am trying to get right along this line. So this is where I'm actually going to take the knob and go up with it. And we're just about there. So now my focal length is set. Also, you want to make sure it's kind of square this way. I'm going to eyeball it, just kind of by moving it back and forth. And it looks fairly good to me. My little red dot is basically worthless. I'm not ever on there, but it looks pretty good to me. I think I'm pretty center this way, and I'm pretty center up and down. So that's where we are so far. So now you see if I move my Y, the cup is actually moving, which is great. It's riding along this, so it's not moving over. And when I move it, it goes. This is where our issue comes into play. You saw if I move it fast, it moves. It might roll off. See, it kind of bounced there. So we need to set the system to not go so fast in our rapid movements. But from now on, I'm going to go over to Lightburn. There's a lot of stuff we need to figure out over there. So let's check it out. All right, so I have Lightburn pulled up. I have my Lightburn camera showing here, and then I have another camera over here. This is the best kind of camera setup I can do while I'm on the computer. But this camera is showing you a little bit more detailed close-up version. So the first thing we need to do, I'm running 9.11 of Lightburn. We're going to go to Tools. So the first thing we need to do is go to Edit. And we're going to come down here to Machine Settings. So we'll click on that. And this gives us a lot of numbers that we won't remember. So what we need to do is we need to remember all of these numbers. This is basically your laser's BIOS. This is, if you change any of these numbers, you're rewriting them and you won't remember what they were before. So we need to save all these settings and be able to remember them, so if we ever do anything wrong, we can re-put them back in. So I'm going to click Save, and I'm going to click Default Laser Settings. And I'm just going to save that to the desktop. If we ever get in trouble, we can click Load. We can go back to our desktop, and we can double-click Default Settings, and it re-puts them back in there. So the other thing we can do is take a screenshot. So if I go to snipping, it brings up the snipping tool. If I click on new, this is of course in Windows 10. I can drag what I want to see. I hit done. It took a screenshot of that. I can hit save, and I can write Lightburn, or I'm sorry, laser default settings. I hit OK, and now we have saved a picture of this. However, we need to look at every single category because we're going to change it in a bunch of categories. So if I click on vendor settings, there's more. If I click on X laser or X axis settings, there's more. If I click on Y axis settings, there's more. We're going to do some things in there. A Z axis, which my machine doesn't have. That's the up and down autofocus. So it doesn't matter to me. U axis, which also I'm not using. And laser settings, which we do use. You can see I have laser 1, laser 2 enabled, but I only have one laser. I don't have multi-tube enabled, so that doesn't matter. This is the maximum power, frequency, and so forth. So go ahead and take your screenshots and save your machine settings. Remember, I'm on Lightburn 9.11, and that will save you later from changing these numbers and never knowing what numbers to get back. All right, so now we're going to go to Tools. We're going to go down to Rotary Setup here in Tools, and you're going to see a picture of Rotary. So it doesn't look like this is our machine. It's a little different. Ours has wheels. These have these basically like hot dog rotaries. That's kind of what I like to call it. If we click up here to chuck, you can see we're on chuck, and that's not what we have. That's got a chuck. That's kind of like a lathe. So the closest one we have is a roller. That's basically what we're going to go with. We're going to click on Enable Rotary because we're changing the rotary. And here we have Y-axis, Z-axis, A-axis. If your machine lets you do other axes, this one does not. It doesn't have a plugin for it. You can choose which one. But we're replacing the Y-axis with our rotary. So when we move the Y, our rotary will move instead of the actual machine moving. So right over here on this side, these numbers seem daunting at first, and they are a little scary. So we're going to skip the first steps per rotation because we don't really know. We're going to skip the roller diameter because we'll figure that in a second. We're going to look at our object diameter and the circumference. So the object diameter and circumference has to do with our actual thing we're engraving on. So I'm going to get that out, and I'm going to get my digital caliper, or you can use a measuring tape. But I have a digital caliper, and if you don't have one, I highly recommend one. I'll put a link in the description below. This just gets you so much more exact than anything else. All right, so I have my can. This is what we're going to engrave. What I'm going to do at first is I'm going to disregard this part up here because we can't engrave on any of this roundedness. So I'm going to start maybe at this point for my overall length. These are numbers we'll need to remember. So I'm going to drag this all the way out. This is my digital caliper. And I'll get a reading of how far we can actually engrave. So notice I'm not doing the curved parts. I'm just doing the flat area. So we're at 4.68 inches. So I'm going to write that down. All right, now we need to know the diameter. And the diameter is from this point all the way across to this point, straight across. This is where the digital caliper really comes into play. So my diameter is 2.926 inches. So that's also a number we'll write down, and let's go back to Lightburn. Okay, the first number we're going to put in here is the object diameter. We are at 2.96 inches. And when we hit tab, that accepts our 2.96 inches. So now we need to figure out our roller diameter. We're doing the exact same thing we did with the can to the rollers. So I'm going to go over and measure. You can see my pointer over here. This roller on this side. How big is this roller? Now you're not measuring the ones that aren't powered by the motor. That's what I'm highlighting right here. You can see we're measuring these two. We're only measuring one, and we're measuring the diameter. Now I'm going to go over and measure it and check it out. And we're at 2.659. You can see I already have this in here because I've done it once. 2.655. We're getting so small that it doesn't really matter. I'm going to leave it at 2.655 because that's a number I knew that worked. So 2.655 inches. I hit enter and it went away. We're going to bring it back up in the rotary setup, and you see it remembers what I put in last. So that's what we need to know. And then the last thing we need to know is the steps per rotation. Now this number is crazy and different for every single machine. This was the hardest thing for me to figure out what exactly this number was going to be. I already know that my correct one is 2,800 steps per rotation. How did I find this? Let me show you how I found this. It's very simple. So I'm back over at the can, and I have some blue tape. So I'm going to put blue tape around my can. This is the easiest way I found to test how it's going to cut without actually cutting into anything and wasting material. So I'm going to put blue tape around one side. I'm going to put blue tape around this side. We could put blue tape across the whole thing. And that's probably what I'm going to do right now, just because I know later on it will be we'll test on the whole can. So here's me putting blue tape all the way across. So there's our blue tape. It's on. Now we want to draw a line straight across the center. So we want to make a mark on one side, a straight line, something like that. That's going to be our starting point. So we want to take something that you have that is a center finder. I just happen to have a center finder from my lathe that it takes that mark, and I can pick that other end and mark it over here. So this is one side, this is the other side, and I know if I laser from here and it rotates and it ends up on here, that is the correct amount for half. So I'm going to go put this on the laser. We're going to start with this line here. And we're going to start with a line here. I'm going to start where my laser head starts right here. And then we're going to type in some numbers and see how far it lasers. So let me go put this in the laser. So I'm just going to move the laser head over that line, and then I'm going to close my eyes and push pulse on the controller so it shoots a beam of light for a split second so it can make a mark, and that's how I'll get that mark right on that line. All right, so you see me shot a line right there. You can see my red dot is not on. I'm going to move that red dot with my hand. That's just a visual helper. I did line up the red dot. Now it's kind of disappeared from the camera. But you can see I've made it to where that dot is right on that line. So now we're going to come back over here and hit OK on the rotary setup, because we need to make a square in here. So we're going to come over here on the side. We're going to grab the square tool, and we'll make a square. And now we're going to change the width and the height of this square. So we knew that the width from here to here, that was 4.68 inches. That's what I got first. So that's from here to here. And if I update my Lightburn camera, you can see my bed. So if I grab this and move it over, you can see we're pretty dead on. That's my width from here over to here. So we're basically looking at this square as if we cut the can on one side and pounded it flat. It would be a square. Hopefully that makes sense. So I'll just disappear the camera. This is where the camera comes into play, and it really helps. If you don't have a camera, I highly suggest it. So this is some options you have to show. So now we need the distance from here to here. And that would, if we go back to Tools, Rotary, and we put in our object diameter, which was 2.960, hopefully that comes out to a circumference of 9.299. So our radius, which was, or I'm sorry, the diameter is 2.9600, comes out to 9.2991. So when we put in our object diameter here, it will also give us the circumference. It does the math. I just wanted to show you that's what it does. So we're going to take this number, 2.99, and that's the difference from here to here. So we'll go back over. We'll click on our square. We'll type it in here. We're going to make sure our lock ratio is unlocked. We're going to paste in, I don't know what it copied there, but that wasn't right. Can't remember what it was. Let's look at it again. 9.299. 9.299. And we hit enter. So if we took the cup and pounded it down, it would be this long and this wide. Now, I want my job to start at the top right. That's where I'm going to start my job, because we're at the right side of it, and I want it to go this way. We're at the top right. So I want it to go down and around. That's what I'm choosing. So we're going to go back to Cuts and Layers, and we're going to turn Output off, because we don't want to cut this square. That's just our boundary. So we know if we put a graphic inside, it will cut something. So we're going to click on blue, or any other color, just some other color than the line we just made. And we're going to make a line. And we know our height is 9.299, so we want to divide that in half. So if we want to make a line that's halfway from this to here, we're going to take our 9.299 and divide that in half. So we're going to make a line. We'll just click somewhere. If we zoom in, we'll click right here. And we'll click there. Oop. That wasn't very straight, was it? Let's try that again. Click here. We'll just go down that line and click there. And then we're going to come over on the button, and we're going to click on there, and we're going to make this line half of that, which is 4.64, and hit enter. You can see that's half, so we're just going to move this down somewhere like that. If we select both of these, and we select top, you can see that now it matches right on that line, and we'll start and we'll cut across. So we're going to cut a line like that halfway through. So theoretically, when I hit start, it'll immediately start cutting a line, rotate that, and cut all the way until the other side, on the back side of that line, I did it. It'll match those two up. That's if our steps per rotation are correct. Now, I know that 2800 is correct for me. That's already been done because I've done this process. But yours is going to have some crazy number, right? I recommend starting at about 5,000. So if I start at 5,000 for purposes of this video, we know that this number's right, we know that this number's right, we know that this number's right, because we put those in and measured them. We have no idea what this number is. So we're going to start at 5,000, and we'll hit start. After we change our speed and power. So I'm going to do this speed at about 15, and I'm going to do this power at about 10, because I don't want it to cut through the tape, because I just want it to cut engrave on this. I'm actually going to do this power maybe at 5. I'm not sure what my minimum power is, but I'm going to do it at 5 at a speed of 15. I'm going to hit OK. So I'm going to try not to... I just want to mark on this tape and not actually engrave the cup. So we got to make sure we're outputting only the blue line. We don't want to have an output on the black line because it's going to cut that and cut the blue line. So we're just going to cut the blue line. So when I hit start, it should start cutting a straight line vertically down. All right. Start from, we're going to choose, typically we're on absolute coordinates, but this time we're going to do from current position, because we're going to tell it you're right here. Because we're kind of messed up with not having our Y plugged in, so it's weird. So we're going to be working from current position. Again, we're going to be working from the top right. That's where I want to start. So we'll hit start, and it should cut that line. You can see that it went way past. It didn't actually cut a line, but that's okay. I visually saw where it went. And then when it finished, it went back home really fast and kind of kicked this out of its normal place. So we're going to have to change machine setting later on to fix that, and that's why we saved the machine settings earlier. But for right now, we're just lining up the laser. So I'm going to go back and reset that cup. My cup is reset. So if you actually cut a line, this line will already be engraved, and we don't want to reuse that. So we're just going to zoom in and just kind of bump it over to the left, maybe about there, so we don't cut the same line. And this is where we'll go back to Tools, we'll go to Rotary Setup, and now we're going to change this number to, say, 4,000. And if we get closer, as if we cut the line was not over the length, it's actually shorter, we know we're going in the right direction. If the line cuts longer, we're going backwards. So if I run this file again at 4,000 instead of 5,000, you can watch it start here, and if it goes and passes that line, we know we're too far. So we'll hit start, and it rotates the cup. And you can see there's our line. It went right past it, so we're over halfway, and it stopped and it came back. You can see there was a little bit of jiggle again, but we know we are still going past it. So again, we'll go to Tools, Rotary Setup. Let's change it to 3,000. Let me reset the cup. And we'll hit start again. You can see here it goes. We already know 2800 is where it was correct, but let's see how much closer it gets. You can see it was right about on right there at 3,000. So this is, once you get pretty close there, you want to start nitpicking and getting super close. The better you can get this, the more accurate your stuff will come out. So I'm going to change it to 2800. And if you bought the same rotary as me, try 2800 first. See what you get. I believe they should probably be the exact same. Our line is lined up. We'll hit start. And remember, we were moving these lines over, but I'm not cutting through, so it's okay. And we hit that line. There's our line. Come to that line, we're good. In the video, it doesn't look like it met that line. It's a distortion of the video because it's round and it's hard to see. But you get the point. We found that number, and that number for me was the hardest thing to figure out for this whole thing. But now we know what our numbers are. 2,800 steps per rotation got us from one half to the other half. 2.655 was the roller diameter. Again, that's the black rollers that are connected to the machine that actually roll. These back ones that move, they're not connected. Don't measure those. The object diameter or circumference, you can measure either one. One gets you one, the other one. So we measured object diameter with a caliper from one side to the other side. That gave us 2.960, which was perfect circumference of 9.299. So we'll hit OK, and we are now done with our calibration. So the other thing we want to do is go into Edit, go back to our... we're going to go into Edit, go into our machine settings, and we're going to change our idle speed right here. We're going to click that, and we're going to change that to 20 for this machine. As it rotated the cup and finished its cutting and rotated it back, its quick rapids, it went 300 inches per minute, which was too fast, and the cup shoots out. I've had cups actually shoot out of the machine backwards while it was cutting. So we want to change this to 20 so it rotates back slowly so it doesn't fling off the rotary. Then we're also going to go to line shift, which is under our engraving parameters. That is 100. We're going to change that one to 20 as well. And we're going to hit right. So that sent the controller 20 for line shift and 20 for idle speed. When I hit OK, we're going to practice. We're going to hit start on our machine. After it cuts that one line, we'll see how fast it returns. So let's hit start. You can see it moved over slower. So we don't want our rotary to go very fast because it's going to shoot the cup. And you can see here's our return, whereas before it took less than a second. Now it's taking a few seconds, but it doesn't shoot our cup out. So I like to go up here and go to Edit, Machine Settings, and I'm going to save the controller settings we have now for rotary with the 20 in idle speed and the 20 in line shift. And I'm going to save that as rotary machine settings. And I'll hit save. So now I can easily switch back and forth. If I wanted to load the normal default settings, I can go to the default settings. I save this in OneDrive, so it's always saved to the cloud so I don't forget. So if I hit load default, we're back to 300, and we're back to 100 line shift. So this was the default. If I want to change it back to the machine settings that we just did for the rotary, I put in the 20 there and the 20 here, and I write it, and boom, we're done. Now just don't forget that when you're done with the rotary and you're ready to go back to laser, you want to change these settings back because it'll go really slow. So we're done with our rotary setup. That was very easy once I figured it out and gave you the parameters. Should be pretty easy. If you have any questions or comments about that, send me a message on the social media or leave a comment down below. Comment down below. Everyone can help you out and put in their 2 cents as well. So we have that finished. So we're going to come back over here, and I'm going to click on this blue line, and I'm going to delete it because now we're ready to engrave this cup. So my wife has chosen a font from DaFont. So I'm going to go to DA font, and I'm going to hit download. And these are for my kids for Easter. So she chose Naville. So I am going to go to search, which is kind of blocked by my camera picture. Make this smaller. So I'm going to search, and I'm going to write Naville and hit search. And that's what my wife wants. So we'll hit download. This is going to download DaFont to my computer. We'll just click on the Truetype font file, double click it, hit install, it will now load it. So after you install the font, I went up here to File, Save As, and I'm saving it as Cup. So it remembers the square, it remembers all the settings. I'm going to close out Lightburn, and I'm going to reopen Lightburn with the machine, with the file I just created called Cup, because we want to have the right font, and we need to restart after we have that font on there. So let me make this bigger. I'm going to click over here, and I'm going to type in Deacon. And we're going to click up here, and we're going to type in N. So there's Naville Demo. That's what she wanted. So this is our cup. So if we did it this way, and I'm going to turn on this one to be blue again, where my laser isn't actually firing. I just want you to see, and I'm going to click here and kind of shrink it down to where it's in the center. Remember that this is where our starting line is, right here at the top. So if I do it anywhere near this line, it's going to start right here. If I do it kind of in the center, it's going to do it on the back side. If I do it over here, it's going to do it at in reverse, on the reverse side. So if let's put it right here so we can see how it goes. If I hit start right now, remember I don't want the black line on because I'm not outputting the square. If I hit start, it should do it right here, and hopefully it'll do it across. And you can see it's now doing the N. So if you want it to go vertically, or if you want to go horizontally across the cup, where we're engraving horizontally, but if you set the cup vertically, it will be not legible unless you turn your head to the side. You put it like we have it right here. If you don't want that, which I don't, I'm going to hit stop. It's going to return itself. I'm going to click on the name, and I'm going to click on the rotate here, and I'm going to rotate 90 and hit enter. So that rotated it 90 degrees. And let's say my wife wants it kind of in the center of this cup. I'll click on the black line, I'll click on the name, and I'll click center. And that centered it from top to bottom, or I guess from left to right actually on our screen, but it'll be from top to bottom on the cup. Now I need to be careful because you can see if you caught this yet, my cup opening is on the left side and my bottom is on the right. And if I engraved it like it is now, the word Deacon will be upside down. So I'm going to click on that and do a 180 in rotation. And you can see now it's going to be, here's my top up here, here's my bottom. So sometimes it is helpful if you bring it into black. And I'm going to type top. And then I'm going to take this and rotate it. You can rotate it like that, or we can do a 90-degree rotation. And if I do that, it's upside down. Let's do a 180 again. So it is helpful to make like a template. So this is my top. And then I can type another one. Bottom. And if I move this over and I put it there, I know this is the top, this is the bottom, and then Deacon's in the center. That's just a template for me to remember. Okay, so these cups kind of have a color transformation right in the center where the bottom is more blue and the top is more green. I'm going to move this. I'm going to move this up just a smidge, probably about there. So I'm not in the color change as much. Maybe one more. I'm not in the color change as much as I would be. It would be totally, out of that color change in the solid green. So what we're going to do is, this is about the size I want it compared to the whole width. And I want to engrave out everything on the inside as well. I don't want just the lines. I want fill and line. I want everything on the inside to be gone. So typically you want to get a extra cup for whatever job you're doing so you can practice engraving on it, because we don't know the speed and power to engrave off the coating that comes on it, because each coating is going to be different. Or if we're going to do a spray onto an aluminum one, we need to figure out the speed and power for that. So this is going to be a guess. I don't know exactly what the speed and power is. I'm going to do my engraved metal on this, and we're going to see how it comes out. So first, again, just to make sure we're doing things right, I'm going to change this back to 5 and 5, but I'm going to keep it at speed 100. That way my laser doesn't actually fire, but I can see where it's going to go on the can. So let's go back to laser. Let's hit start and see what it does on this can. So you can see how much higher it's going than I actually want it. It's really close to the tip. So I'm glad that I didn't start that where it was. That's why I always recommend running the laser with the laser off first. So I'm going to move it to there, and let's hit start again and see what happens. That's still a little high for me. I'm going to move it down one more, hit start. And that's looking really good to me. So we think we have our positioning correct, right? I'm still on line, so I'm going to change it to fill end line, sorry. And we'll hit start just again to make sure we're right. And this is how it's going to look. We'll let this program run all the way for the first one, especially since I only have 2 mugs. Typically, if you had an extra mug to practice on, you just go for it and you'd be ready. But I don't have an extra mug if I screw this up. So here we go. We're cutting. And I'm just going to speed this up so you can see what it looks like. Okay, so we can see that whenever it did the line, it actually engraved some more than it did. I'm going to take the tape off, and we're going to fire it up and go. Okay, change the power to 30. My speed is at 100. Tape is off at the top. I'm doing the other side because I did leave a little bit of engrave mark on the one side, so I'm lining it up at the bottom side. So he'll have a little name on both sides. This one should look a lot better. So we're ready to go. So we'll come down to laser. And I have the exhaust now and the air assist on, so it'll blow all that away. And I'll hit start, and it'll start cutting. Let me change this over to camera control. Again, we're going to make sure that our black line is not on, or just our blue line. We're only cutting the blue line. So here we go. All right, so I royally screwed up on the one side because it slipped and moved. I was going too fast in the speed. So this is where I showed you earlier what it was up. So I slowed the speed down to 50. I'm going to change the power down. I'm going to keep the power at 30 because it doesn't really matter. We're not going to cut through that aluminum. And I'm going to hit start. You can see where the N and the O kind of covered each other up. But now we're cutting out his name. We're just going on fill. So everything's moving slowly in the Y rotation, which keeps everything straight and good. So enjoy the cut. Here's where I first did it. It was going okay until it needed to do the C&Os and the curves. It was at 100. It was just too fast for it. This is why you always going to get 1 cup to make sure that you're cutting right. So that's a screw up. But this one turned out really well. Turned it down to 50. It can handle 50 just fine. And it it looks good. So I do have like that initial engraved behind it, because you can never line up the cup again just right. I can't. Maybe you can, hopefully you can. But that's what it looks like. It came out legible, readable. If you look over there, you can see what it's supposed to look like, just like that. So that's how you do a cup. I'm now going to do fissures. I'll show you fissures. He'll get one shot and it'll come out and be done. So I'm going to come in here, click on this tool, delete the name, put in fissure. Zoom out. That's all I'm doing different. I'm just keeping fill and line exactly how it was, because that was fine. I'm just going to keep it on fill, camera control. So I'm going to hit start. I'm going to put the thing back in there, the cup, and we'll hit start. All right, you can see fissure just finished. That was a great cut. This is why you always have a spare cup. But now both my kids have a named cup for Easter. All right, we're finished with our rotary. We did our job. Very important to remember. We need to go back to Tools, Rotary Setup, and Disable Rotary. I also have added the selection over here in Laser. That's a setting you can turn on in Tools Preferences. So we're disabling the rotary, and we're hitting OK. We're also going to go back into Tools. We're going to, Edit, Machine Settings. We're going to load, and we're going to find our file that has the default settings. We're going to load that. So we're back at 300 idle speed and 100 line shift speed. We're going to write that to the controller and hit OK. And now we're back into normal mode where we're cutting flat things and not using the rotary. Very important step. Don't forget to do which one's which. It's very akin to when you have a dishwasher and you think that the dishes are dirty and you stick a dirty dish into your clean load. So make sure that you change that back. First one. There's where it did it wrong on the C and the O. Don't go too fast. 100 was too fast for my machine. So here is the good one. This is fissure. Focus, there you go. You can see it says fissure. And there's no other marks on this one. So this is your production line once you get it dialed in. Looks pretty good. So matching mugs. So this is a follow-up really to the video of did I waste $2,400 on a Chinese laser? The answer is no. It works amazing. Also, the laser rotary works amazing. I have made my money back and then some within the first month of buying the laser. I love it. It's great. I'll leave a link for that down below. You can purchase it on Amazon or eBay, or you can watch the video that I did originally where people called us idiots for pushing it across the yard. But hey, I didn't have another way to do it, and I didn't want to spend money on plywood, and it worked out perfectly fine. It's sitting right over there a year later and still cranking it out. So if you buy the laser and you have any questions or comments, hit me up. I'll be glad to help you. Again, I've only ever used Lightburn with it, so I don't know any other program to work with like RDWorks or anything like that. So if you're using Lightburn, which I highly suggest you do, it's an $80 purchase for a big laser like this. It is well worth the money, and those guys offer fantastic support. So let me say thank you to the guys over at Lightburn for their forums, for giving some great documentation over there. Check them out. I'll leave a link at Lightburn down below. And I think it's a great program you should buy. Works great for the laser, and it's an American-made company. So hope this helps. Thanks for watching. And as always, happy lasering. I don't know what I'm saying. Hey guys, it's Ben with Myers Woodshop, and today I want to go over an accessory I just got for my 60-watt laser, and it's this rotary.